Okay, Assalamualaikum warahmatullahi wabarakatuh, and my name is Nur Munir binti Syari. My metric number is AF200015. So today I will present about the introduction of our projects. So the plate structures are widely employed in a variety of engineering disciplines, including aerospace, mechanical, and automotive engineering. Plate deflection theory is more difficult than beam deflection theory. Plate is a structural element which is characterized by a three-dimensional solid whose thickness is very small when compared with other dimensions. Analytical solution based on elasticity theory exists for many types of beam as well as plate problems. However, there are several complete plate structures for which an exact solution often is difficult to find, and hence numerical solution for such cases can serve as a good alternative approach. So, the consequences of the loads that are predicted to be applied to it only produce stresses that are exclusively normal to the element thickness in practice. The plate theory is primarily concerned with their mechanics. Thin plates are flat structural components with two parallel planes known as faces and cylindrical surfaces known as an edge or boundary. The generators of cylindrical surface are perpendicular to the plane faces. Thickness h of the plate is the distance between the planar faces. The plate thickness will be assumed to be small in comparison to other face characteristics as length, width, diameter, and etc. Plates are geometrically defined by straight and curved boundaries. Plate loads are mostly perpendicular to the plate faces, whether static or dynamic. Folded plate structures are assemblies of flat plates or slabs inclined in different directions and joined along their longitudinal edges. In this way, the structural system is capable of carrying loads without the need for additional supporting beams along mutual edges. This technology was developed in Germany in 1920s and was widely used to construct roofs for industrial warehouses and public buildings in Russia and the United States throughout the 1930s. Cast in situ or precast reinforced concrete or steel plate are commonly used in modern folding plate structures. They come in a variety of shapes and sizes, including prismatic, rectangular, pyramidal, non-rectangular, prismoidal, triangular, and trapezoidal plates. Folded plate structures are cost-effective over lengthy spans that must be free of internal columns and other impediments due to their inherent rigidity and great load carrying capability. So that's all from me. Thank you.
My name is Nur Aitra Yasmin binti Muhammad Radwan. My metric number is AF200023. So, I would like to talk about the background study for this project. In this project, we discuss about the folded plate structures. The terms folded plates refers to a configuration in which assemblies of flat plates are firmly linked together along their edge. Folded plates are joined together in such a way that the structural system may withstand load without the requirement for extra supporting beams along the mature edges. The folded plate structures method was developed in Germany in the 1920s. Later, during the 1930s, this folded plate structures technology became popular in Russia and the United States for the constructions of roofs, of industrial warehouse and the public buildings. Nowadays, the folded plate structures are commonly built of cast in situ, precast reinforced concrete or steel plates. The folded plate structures have numerous advantages in the construction industry. The plates or slabs utilized in folded plate structures are easier to produce than other shells such as cylindrical shells. The frameworks need for folded plate structures is simpler than for other structures. Other than that, fewer materials are required for the building of folded plate structures. They require more resources than curved shell if there is greater bending involved in the construction. Finally, for the plate structure are economical over long spans that need to be free of internal columns as folded plate structures have intrinsic rigidity and high load carrying capacity than other structures. Each plate is supposed to be as a beam in its own plane. This assumption is justified when the plate spans length to height width ratio is low. The plate behaves like a dim beams. That's all from me. Thank you.
Hi, my name is Liana Natasha binti Muhammad Rashid. My metric number is AF200024. So I'm going to talk about alternative methods of plate structure. As we know, structures undergoes the stress. So stress can distribute the certain manners of kind of stress. One defects that is commonly in plate structure is the fractures which produce stress contraction factor. Concrete structure monitoring is carried out of discover deteriorations in the structure, measurement and analysis the carry out to fix the problem of the structure so that we can assure the building ability. When the structures undergoes load, the certain element will experience the stress. So to identify the stress in a plate structure, we can calculate the stress using Hooke's equation, which is the connection between the stress and strain are used in this formula. In other way to calculate the stress used also can be used as Hooke's equation, but by assuming the stress in formula as 0, so that this formula, all this kind of formula can be solved, where D is equals to elasticity modulus material time height cube divided by 12 time 1 minus velocity squared. So all these kinds of formulas can represent as a moment and stress that occur on plate. This equation really related to stress equals to m time y divided by inertia, when inertia is equals to height cube divided by 12. So stress can samples made under the correct circumstance are not significantly different from the measurement that taken is in the normal conditions. So as a conclusion, both method can be used to identify the stress on plate, but because both can get the same value of stress, so when value of stress can be known, so bending moment also can be known. When we know this, both stress and bending moment, cost for every project made can be prevented.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nora Dila binti Muhammad Ahmad. My metric number AF200001, and I will present about the recommendation. First, assumption of the plate theory. Plate theory and beam theory. Plate theory is an approximate theory. Assumptions are made and the general three-dimensional equation of the elasticity are reduced. Only with an extra dimension, it turns out to be an accurate theory provided the plate is relatively thin, as in the beam theory, but also the deflection are small relative to the thickness. Assumption of plate theory. Okay, we have a plate structure. Okay, let the plate mid surface lie in the XY plane and the Z axis be along the thickness direction, forming a right-handed set. The stress component as seen on a typical element of the plate as shown in figure 6.1.5. Okay, the following assumptions are made. The mid-plane is a neutral plane. The middle plane of the plate remains free of in the plane stress or strain. Bending of the plate will cause a material above the below this mid-plane to deform in plane. The mid plays the same role in the plate theory as the neutral axis does not in the beam theory. Second, line elements remain normal to the mid-plane. Line elements lying perpendicular to the middle surface of the plate remain perpendicular to the middle surface during deformation. Okay, figure 6.1.6, this is similar the plane section remain plane assumption of the beam theory. Third, vertical strain is ignored. Line elements lying perpendicular to the mid-surface do not change length during deformation, so that the strain Z equal to 0 throughout the plate. Again, this is similar to an assumption of the beam theory, classical plate theory of the Kirchhoff plate theory. So, this is a stress in a plate. The normal and inner plane shear stress have been represented in terms of moment. It is worth noting that these stresses are zero at the mid-surface and reach the highest at the outside surface. The equation of equilibrium can be used to get expressions for the remaining stress components. So, this is the formula that we always use. From the recommendation from the theory given, there are three shapes of plate structure: prismatic, pyramidal, and prismoidal. Several benefits were found in the plate construction. Plate structure also become a shelter concept for a portable shelter for homeless people such as in Bangladesh because it's cheap and easy to get. The shelter called recover accordion shelter and lightweight emergency shelter. The shelter can be handled by one person only for a couple of minutes. The shelter also can be delivered as a flat sheet of compressed into a Hosho-shaped panel stack. Lastly, the recommendation for future study is changing the shape and thickness of plates. The rigidity of the plate varies inversely to the amount of information utilized as the plate thickness increase and decrease. So, that's all from me. Thank you.
For the solution, a structural steel triangle plate 1/4 inch thick shown in figure 3 is bolted to a steel column with 3/4 inch diameter bolts in the pattern shown. Assuming the column and the bolts are very rigid relative to the plate and neglecting friction force between the column and the plate. The question is, determine the highest load exerted on any bolt. The bolt should not be included in the model. Just fix the knots around the bolt circles and consider the reaction at the knots as the bolt loads. And the second question is, determine the maximum von Mises stress in plate around the circle of the bolts. As you can see, this is the calculation of the previous question. We have to find the direct load on one bolt, torsional force on the bolt to find the highest load on the bolt. Then we have to calculate the direct shear stress and torsional shear stress to calculate the total shear stress, and the major and minor principal stress to calculate the max stress using the von Mises theory. In conclusion, plate structures are widely used in many engineering fields, for example, aerospace, mechanical, and automotive engineering disciplines. In this project, we have discussed how the plate structure works in engineering application. Thus, we studied that the plate can be manufactured from such isotropic materials as a steel, aluminum, or titanium alloys. As a result, this research can assist engineers in selecting the optimal plate structure for each project. This explanation and details can provide a future engineer with a broad understanding of how to consider all aspects of plate structure. This research also includes several experiments that can be used as a reference by interested parties. That is all from our group. Thank you.